My name is Kellen Rowe, and this is my presentation over G protein receptors and G proteins. There's more than 1,000 different unique types of G protein receptors in the human body, and these all start a chain reaction that cause secondary messengers to come through the cell, and they all have unique different functions. So there's 1,000 different ways that G protein receptors start a process in the human body. There's different things that will start the chain reaction, and these are ligands, and they bind to the outside of the G protein receptor, and these things can be light sensitive. They can be odors, pheromones, hormones, or neurotransmitters that act as a ligand, and they can be regulatory for many different bodily functions, and these things can be like taste, smell, visual, behavior, and even mood can be controlled and regulated by these G receptor proteins and the G proteins and the G protein receptors. G proteins interact with the G protein receptors. They're a unit, and they act as one to create a chain reaction throughout the cell. So the G receptor protein has 7 transmembrane alpha helices, as you can see in this image, and they all form a curved shape, as you can see, as they go up and down and create curves. There's always going to be 7 of those, and that's what helps to make these unique. And then for the G protein that is not shown here in the image, there's always 3 subunits, and these 3 subunits are going to be the alpha subunit, the beta subunit, and the gamma subunit. And the alpha subunit is what is going to bind to the GDP, and when activated by the ligand, it will bind, instead of the GDP, it will bind to a GTP. And the 3 subunits are bound to the cell in the lipid membrane with lipid anchors. So for the signaling process, the ligand starts the conformational process, and then the alpha subunit will bind to GDP after the G protein receptor undergoes conformational changes that cause the alpha subunit to bind to GTP. And then after that happens, the beta and gamma subunit will dissociate from the alpha subunit, and the alpha subunit will find a target protein, and then the target protein will take the energy that comes from the GTP and breaking that down into a GDP, and that target protein will release a secondary messenger, and that secondary messenger will create a unique signaling response throughout the cell to do a specific function throughout the cell. Yes. And so a real life example of this is the alpha subunit will target phospholipase C, and so once this G protein coupled receptor binds here, this is the G receptor protein, and this is the alpha subunit, and then the beta and gamma subunit, and then the GTP will create separation, and then you'll have the dimer between the beta and gamma subunit, and then you'll have the alpha subunit, and then these will create 2 secondary messengers, DAG and IP3, and these are used for a variety of human processes, but the most well known, and what I've been taught in my pathology classes throughout my chiropractic program, is that it's used to activate the thrombin receptors and platelets, and promotes blood clotting throughout the cell whenever there is an injury through hemorrhage somewhere throughout the body. And these are my sources for the presentation. Thank you for listening.